So we're having this system, three-dimensional system. We're having the x-axis, y-axis, z-axis. We know the angle between them is 90. So the unit vectors are I, j, and k. I is unit vector along x-axis, j is unit vector along y-axis, k is unit vector along x-axis. If I write here I dot j, we know that the angle between them is 90. So the dot product is 0. Same is when I take j dot k, the angle between them is 90. So the value will be equal to 0. I have k dot I dot k, same thing, because the angle between them is equal to 90, so this is equal to 0. If I multiply vector I with vector I, so I'm going to get, I get magnitude of vector I into magnitude of vector y in cos of the angle between them, cos of them is 0. So magnitude of vector I is 1, I is 1, cos 0 is 1, so I dot I is equal to 1. Similarly, I can take j dot j is also equal to 1, and k dot k is equal to 1. The important result, sometimes we need them for solving our problem. So we're having the system xyz, three-dimensional system. Angle between them is 90, so that I dot j is 0, j dot k is 0, k dot I is 0. So when you take I dot I, because the angle between them is 0, cosine 0 is 1. So magnitude of I is 1, magnitude of I is 1 is equal to 1. Similarly, we can find j dot j and k dot k, that's also equal to 1. Next idea is that we want to find component of a vector A along B. Component of a vector A along B. Before going to this one, I just may want to make the revision of this trigonometric function. For example, I am having here the vector A, this is my vector A, and this here is my B, the length of the vector is B. It's my triangle, right angle triangle, this is my C, angle is theta between them. So you know we can define the cosine theta. My cosine theta is base over hypotenuse, that's B over A. I have the sine theta, my sine theta is opposite, that's equal to C over A. From A over, from this one, the first equation, we can say we can write here this equal to, if we want to write the value of B, so the value of B is equal to A cosine theta, A is the length. And similarly, we can say if we want to find the value of C, C is equal to A sine theta. Most we say we have the component, force component F, and angle here is theta. I want to find the component of this one. So along theta we say is F cosine theta, and I say here opposite to theta is F sine theta. So mostly in physics we are using, we can find the component of a vector of along theta and opposite to theta. Here I am doing the same thing, that I am given here two vectors A and B. I have here vector A, this is my vector A, and here is my vector B. Angle between them is theta. I want to find the component of vector A along vector B. I draw a perpendicular. So I am having here for the component, this is the length. This length is component of vector A along B. How I find this one? This length is here is component. I write here component of vector A along vector. It's very easy to find it. I want to find this length. I apply this formula. That was my this length. This is my component of A along B. What this will be equal to is magnitude of vector A, because this is a vector. So we take here this was another vector. Vector is a magnitude into cosine of theta between them. So that gives me the component of vector A along vector B. So I can just redefine this one. I just multiply here. I write here the component in another form. I say it's component of A along B. I'm having here A cosine theta. I multiply by its magnitude of B and divide it by the magnitude of B. I rewrite this one. I can write this one is magnitude of A, because the scalar we can write anywhere we like. Here is cosine theta. This is here cosine theta, and divide by magnitude of B. So if you can see, this is our definition of A dot B over magnitude of B. So that we have another way of writing. Another way of writing or looking at this one is very interesting. I want to find the component of A along B. I take dot product of this one with the unit vector along B. So I can have here this equal to A dot unit vector, the direction of B. The direction of B is B over magnitude of B. They are all equivalent. So we can write here the component of A along B is magnitude of A cosine theta. Are we write A dot B over magnitude of B? Are we having A dot magnitude of B over magnitude of B? So this way we can define the magnitude of A along B. So from here we can have the ideas that we having any vector. We can find the magnitude of that along the vector. We can get it. For example, I am having here, this is my vector U. I want to find the component of this one along vector W. So I have here the perpendicular. So I can write here component of U along W is equal to what? U multiplied by the unit vector along W. That's W over magnitude of W. I will say we having here U dot W over magnitude of W. So we can do it. We can say here, for example, you want to find the component of vector B along vector A. So what will this one? B into A over magnitude of A is equal to B dot A over magnitude of A. In practical speaking, it's things like this one. For example, here is some mass or some body, and you are pulling this mass with this force F, and here is this direction you are going to take it. So then we want to find the force component along this one. The force component along this one will be F. If this is angle theta, this is F cosine theta. That's the horizontal component. If we take the vertical component, we are just rising it up, then what we'll get? We get here F sine theta. That's along z-axis. We're getting the direction of this one. This along y-axis, or along this component is cosine, and that will be sine. So that's why we are having all this one. This is some body, and we are just pushing it that one. That is the value we'll get here. There is some other extension of this one, that we want to find the projection of this vector B, A on B. So projection will be a vector value. We're having here, this as the projection want to find. This is my A, and here is my vector B. This is my vector B. I get here. Then I'm having here the component of, this is my component of vector A along B. Now I want to find the projection. The projection of A along B will be a vector. And what we do, we multiply this component of A along B with the direction unit vector. What is my unit vector? This is my scalar. My unit vector will be over magnitude of B. And that's my definition of the projection. We can write here, this is what? This is A dot B over magnitude of B, and here we multiply B by magnitude of B. I'll explain you this one with the help of the example. We have another example. We have two vectors A and B. Want to find the component of A along B, component of B along A, and projection of A along B, as I explained you before. We use these ideas and we find the result for that one. For the component of A along B, mathematically we are speaking, we can just take here the component of A along B will be equal to A dot B or magnitude of B. So we are taking the component along B, so it's to be divided by we multiply by unit vector B, a magnitude of B. So we find A dot B. So my A dot, this is my number A, the first one. And instead of A, I will like to write here 1, because A, B we are using as the vector, so it's better we change this one and say is 1, 2, 3. So I take here as number 1. So my component of A along B, first I find A dot B. So the dot product A dot B is 2 into 1 is 2, 3 into 1 is 3, then minus 4 plus 2 is minus 8. We get here 5 minus 8 is equal to minus 3. This is A dot B. I find magnitude of B. So magnitude of B is equal to root of, this is my B, is 1, square is 1, 1 square is 1, and here is 4, we get here root of 6. So I will write here the component of A along B. The component of A along B is my A dot B over magnitude of B. My A dot B is equal to minus 3. We get minus 3 over root of 6. That's my solution for the component of A along B. Now I find number 2. Number 2 is component of B along A. So what will be that? That's B dot A over magnitude of A. Now what's my B dot A? My B dot A is same as A dot B, and we have calculated here A dot B, or A dot B was equal to 3. So this is also equal to minus 3, and then we take magnitude of A. What's magnitude of A? Is root of A1 square plus A2 square plus A1 square is 4, A2 square is 9, and A3 square is 16. Is 4 plus 9 plus 16. 16 and 4 will give me 20. I'll give me 29. So I can write my result. The component of B along A is equal to B dot A over magnitude of A. B dot A is minus 3 over, we are having here root of 29. So that's my number 2. Number 3 is a projection of A along B. Number 3, we want to find here the projection of A along B. What's that one? We just have the component of A along B into the unit vector along B. So this give me here A dot B over magnitude of B into B over magnitude. This will be a vector. This will be a vector. This give me here A dot B. We know A dot B is our minus 3. Minus 3. We can write the result here. This is equal to minus 3 over. Then magnitude of B is root of 6. Here is root of 6. And then I have here B, my vector B is equal to, my vector B is I plus j plus 2k, I plus j plus 2k over magnitude of B is root of 6. So don't simplify this one. Then 3 root of 6 become here 6 into, we having here the I plus j plus 2k. Then minus 3 over 6 is equal to, we simplify it, is minus 1 over 2 into I plus j plus 2k. I've simplified further. We get here minus 1 by 2 I, this minus 1 by 2 I, minus 1 by 2 j. Then we are having here minus k, because we divide 2 by 2, that give me 1. And now this is a projection of this one. A projection is a vector. We have seen here, this is my projection of A. The projection will be a vector. So get this vector again. We are having 3 things. We find component of A along B, component of B along A, and projection of A along B. We have block here, and we apply force F to displace this block from point P to point Q. So we say the displacement is D, and D is a vector. Displacement is a vector. Distance is a scalar. So when you find the component of this one, if this is making an angle theta with the direction of the force, we're having the horizontal direction in direction of the displacement, this will be F cosine theta. We say here this is component of vector F along vector D. So that will be F cosine theta. So we can find the component of F along D is F dot D over magnitude of D, and this here is force multiplied by the distance is the displacement. When we take here this and we cancel this one, this is the scalar product of the force and displacement. Force is a vector, and also displacement vector in this dot product will give me the work done. So we are given the force in terms of the vector, we given displacement in terms of the vector, and we can apply this formula to find the work done by that. We are having here the constant force is being applied to point Q, to point P, to point Q. So we can see, as been given the last example, what will be our work done. Our work done will be equal to the force multiplied by the displacement, this vector PQ. So I given the vector force is given to me, PQ I have to find. I find the vector PQ. Vector PQ is equal to Q, this is x2 minus x1, 4 minus 1, y2 minus y1, 6 minus 1, z2 minus z1 is 2 minus 3. And simplify this one, I get here vector 3, 5, and minus 1. Now I have 2 vectors, I can take the dot product of this one. So my work done is equal to F dot PQ. Now given the vector F, my vector F is given to me is 2, 4, 1, 2, 4, 1. Dot product with PQ is 3, 5, minus 1. We take the dot product, we get 6, A1, B1, A2, B2, A3, B3 is equal to minus 1. And we get here this equal to 26 minus 1 is equal to 25 units. And that's the work done by the force. When taking displacement from P to Q, we can have different type of scenarios. We can have the force. There are 3 forces working, F1, F2, F3. We take sum of the force, that my force. We're given the magnitude and given the direction separately, so we have to find the force. We're given the force, the magnitude, we take the unit vector along that direction and we get the force, we get the displacement. I have different examples given in my notes. As I said, you can just go down in the description and you can download my notes. You'll get more examples and more problems for the practice. Assalamu alaikum wa rahmatullahi wa barakatuh. Our next lecture will be inshallah about the vector product.